Okay, in this particular video, we are going to be going over interpreting scatter plots and predicting values, and these are the examples. So I know my graph printed off a little bit crazy, but this is talking about beats per minute. And then it's per minute of exercise that is on the bottom. So the number or amount of exercise, and it goes up by tens, I think 10, 20, 30, 40, 50. Okay. And then also you guys have a copy of this in Google Classroom as well. But anyways, okay, so example number 1, Samantha recorded her heart rate after exercising for different amounts of time. She created the scatter plot below. What is the equation of the line of best fit? So you need to take these points that are located inside the scatter plot and estimate what point values you think that they have. And then where I listed them off to the side on a separate sheet of paper, and then I went into Desmos.com and I created a table. So again, I'm going to go into Desmos. Here is my example number 1. I went ahead and I went to add and then a table. Check out another video where I walk you through how to find the line of best fit and within Desmos.com. But this one, assuming you already watched it, we're good to go. So you're going to insert a table. You're going to put in your table values, and then you can have to zoom out so your values have been shown. You can zoom back in, okay? And then I found my equation, y equals mx plus b, but this is the funky format that Desmos needs to use, so you are able to find the equation of the line. My slope is 0.6, b is 75. So again, I'm going to go ahead and take note of that equation. So what is the equation of the line of best fit? Y equals 0.6x plus 75.6. Okay. The next type of question is discussing what is my scatter plot actually talking about. So what is the slope or my unit rate described in words? So remember that slope is y, the change in y over the change of x. So we're going to look at our y-axis versus our x-axis. So this one is talking about beats per minute of exercise. Okay, so beats per minute is on the y-axis. So beats per minute, and then she's exercising. So beats per minute of exercise is what we are looking at. Okay, based on the linear model, which is the linear equation, linear line that's graphed inside of here. Okay, what is the meaning of the y-intercept? So your y-intercept is somewhere in here, and then in my equation, it actually came out to be 75.6. And if you notice, it has an x value of 0. So my y-intercept is 0, 75.6. But what does that really mean? Well, the x-axis is minutes of exercise. So 0 minutes of exercise, her heart rate is already at 75.6. So if it's at 0 minutes of exercise, which one matches that description? So is it the increase in Samantha's heart rate each minute of exercise? Is it her heart rate before she exercises? Again, we're at 0 minutes of exercise. Or is the amount of time that she is exercising? So if we're at 0 minutes, and her heart rate is already at 75.6, that is happening before she exercises. And again, the keyword was 0 minutes, or the key part was 0 minutes. Okay. Why does it make sense that this y-intercept would not be down at 0, 0? Well, using some common sense, if your heart rate is at 0 during 0 minutes of exercise, like you're going to be dead. So even if you're not exercising, you still have a heart rate going on. So someone's heart rate at 0, 0 would end up being dead. That's what I'm going to write down. Or before you exercise, you're still going to have some type of heart rate going on. Okay, what would Samantha's heart rate be after an hour, which is 60 minutes of exercise? Well, we have an equation now where we're going to predict our values. So first, let's remember what's on each axis. X-axis is a minute of exercise. Y-axis is your beats per minute. This question is giving us 60 minutes. So 60 minutes is going to go in the minute spot, which was X. So up here we have Y equals 0.6 times 60. Again, I knew it because 60 minutes was given. Minutes is on my X-axis, which is going to go in for X into my equation. okay, plus 75.6. Okay, when I did 0.6 times 60, I got 36, but I need to add 75 to that, or 75.6 rather. Okay, so y equals 111.6, and y is my beats per minute. So her beats per minute, or her heart rate, let's just simplify it, her heart rate is going to be at 111 beats per minute. Or we can round up to 112. And that's after she has worked out for an hour based on the linear model that was given. Okay, how long would Samantha have been working out for her heart rate to reach 131.8 beats? Okay, so this one gives us the beats. So let's look at our scatter plot. Minutes was on our X though. Beats was on the Y. So 131.8 is going to go in for my Y value instead. So 131.8 equals 0.6 X plus 75.6. So solving our basic equation, you're going to need to subtract 75.6 from each side. 131.8, 75.6 minus that, and you get 56.2 is equal to 0.6x. Okay, this is multiplication. Opposite of that would be dividing by 0.6. And so x, which was our minutes of exercise, is 93.6 repeating. So I'm going to round that to 95. So after 94. So after 94 minutes of exercise, her heart rate would be around 131.8 beats per minute based on the linear model that was graphed within the scatter plot. Okay. Example number 2 now, we have a different type of scatter plot. And this is representing the average height of girls from birth to 12 months of age. Okay, what is the equation of the line of best fit? So I went through and I looked at the data that was given on the scatter plot and took my best estimate of the data points. And I went into Desmos.com. It was example 2. Open that graph. Okay. And within Desmos.com, I graphed my table. I found the equation y equals mx plus b and Desmos funky formula going on here. And my slope is 1. And my y-intercept is 19. I'm going to go ahead and round that. Okay, so what is the equation for the line of best fit? 1x plus 19. Okay, let me scoot this back over. Okay, so y equals 1x plus 19. What is the slope unit rate in words? Well, slope is the change in y over the change of x, rise over run, y over x. Okay, this is height, and this is talking about age. So the height per age, or this was inches per month. Okay, so let's just do inches per month. Okay, based on the linear model, which is the equation or the line of best fit that you would draw in here, okay, what is the meaning of the y-intercept? So the y-intercept always happens when x is 0. So at 0 months, you're going to have a height. So 0 months will be when the child is first born. So the height of the baby when they're born. Okay, now why does it make sense that the y-intercept is not at 0, 0? Well, whenever you're born, a child has a height to them. So you are born with a starting height. Or you're born with height, you're born with a starting height. Okay, something along those lines. Like you're not coming out and you have 0 height to you. Like you come out whenever you're born with a height. Based on the linear model of the data, what is the approximate average height of a 16-month-old girl? So here's my key information, 16 months. Okay, months is right here, even though it's kind of cut off. Okay, and then this one was inches. Okay, so months is what it gives us, and months was on my x-axis. So I'm going to go into my formula or into my equation, and I'm going to plug 16 in for x. Because again, 16 months. Months is here, x-axis goes in for x. So we're going to do y equals 1 times 16 plus 19. 1 times 16 is 16 plus 19 is 35. So a 16-month-old girl would be 35 inches tall. Okay, so again, we were taking our information in our scatter plot. We were estimating the points in our scatter plot, placing them into Desmos.com, getting our line of best fit, and then answering some practical questions about how to interpret what's going on in the scatter plot, and then using our line of best fit to either find an X value or a Y value, and you have to pay very close attention to what your question is asking you for, looking at the different axes and then plugging that information into your equation to find out what it is asking. Hope this video has helped you, and best of luck.